Okay, we're gonna go over worksheet number 1, definition types of data, levels of measurement. This corresponds to the book section 1.1. Book section 1.1. So if you need more like detailed information, you can kind of read through section 1.1 as well. So before we get started, we're gonna start with like an example. So let's say I'm interested in how many people have exposed to COVID-19. How many people in LA? How many people in LA are exposed to COVID-19? Well, this will be kind of hard question to answer because for a few reasons. Because there are just so many people in LA. How are we going to survey every single person? So first reason would be this is going to be a hard question to answer. Hard to answer because A, there are so many people. I mean, that's mainly the biggest problem we have to actually get this answer. And two, maybe it's just too expensive. How are we going to test every single person? How to test everyone? Maybe it's too expensive to do that. Right? So even though it's an interesting question, a lot of times we have issues because A, there are so many people, and B, how are we going to test everyone in the group? So this is basically the concept of statistics. We have this big group of people and we want to say something interesting about it. But in real life, it's just going to be very difficult or impossible to do it. So what we do is to take a small group of people from big group, and then by studying the small group, we can say something about the whole population. So that's our first concept. We have the concept of population and the sample. So population is everyone, every element, or objects, or people, person that we are interested in studying. That we are interested in studying. So drawback here is in reality. In reality, it's hard to get the information. It's hard to get information from the population. It's hard to access the information from population. So in real life, what we do is we'll take a sample. Sample is a subgroup or portion of a population. Of a population. So in real life, this is what we study. In real life, in reality, this is what we study. Okay, this is going to be like theme throughout the semester. So we'll always refer to population and the sample. In the last 4 or 5 chapters is all about how can we use a sample to say something about population, because we're not surveying every single person, so there's going to be always difference between population and sample. In the last 4 or 5 chapters is all about studying like how do we say something about population by using sample. Right, so we'll revert back to this concept over and over again. Next concept is a parameter and a statistics. So we'll give different parameter is numerical property of a population. So basically what it is numbers you calculate. Numbers we calculate from population is called a parameter. So let's say, oh, maybe 50%, or maybe 50% is too high. Maybe 20% of all people in LA is exposed to COVID-19. So that 20% that we calculate from the population is an example of a parameter. Statistic, on the other hand, statistic is numerical representation of property of this sample. This is numbers we calculate calculate from the sample that we have, right? So let's say, for example, in reality, instead of surveying every single person in LA, maybe I'll just survey 100 people. And out of those, I want to see how many people are exposed to the COVID-19. So whatever number I calculate from that sample is an example of a statistic. So maybe from sample is 25%. So 25% is an example of a statistic. The next terminology is a variable. It's a characteristic or measurement that can be determined for each member of a population. The variable may be numeric, which is numbers, so numerical. Basically, it's a number. Or it could be categorical. Categorical means like a description or like a name, so on and so forth, right? So when I do the survey to see how many people are exposed to COVID-19, when I do survey, it's going to be basically, are you exposed? The answer is going to be yes or no. So that'll be an example of categorical variable because the data I'm going to collect is either yes or no, it's a description. If I ask people like how much money they spent on something, then they'll give you like a number answer. That'll be an example of numerical variable, and we'll talk about that in more detail later on. The data is actual values of the variable, so this is what we collect, right? This is what we collect. Okay, now I'm going to have you pause and start working on number 8 and number 9. This is kind of reinforcing the concept we just learned, number 8 and number 9. Okay, next we're going to talk about types of data we're going to be collecting. So as I mentioned before, data can come in as a number or they can come in as name or description. So when we ask people, hey, are you exposed? I guess we don't ask them. But when we test people, either they're exposed or not exposed. That's an example of qualitative data where the data we're collecting is a category or description. So qualitative data is data that is either description or category or like a lot of yes, no question are example of qualitative data. So I'm collecting if they have it or not. So that's a yes, no question. That's a qualitative. Let's say I'm collecting a student's major. So I can have psych major, philosophy major, nursing major, whatnot. These are description or categories, right? So that's the example of a qualitative data set. Whereas quantitative data set is basically numeric measurement, numeric numbers, numerical measurement, or count, right? So for example, if I ask, hey, how many units are you taking this semester? I'm taking 12 units, I'm taking 14 units. That's a number, and that's measuring or counting how many units you're taking. So these are like how much or how many or how much type question, most likely a result in quantitative data set. Quantity just means like count how many, right? That's why it's quantitative. It's called quantitative data, whereas quality is like a description. Quantitative data set, we can even further split into two different types. This discrete and continuous. So discrete is where there are impossible values within a reasonable range. Whereas continuous data, all the values are possible. Values are possible within a data, within a a reasonable range. Reasonable range. So for example, if I ask you guys, hey, how many siblings do you have? How many siblings? Possible answer I can get is maybe I have two. I have two siblings. Maybe I have 0. Some of you guys have a big family, 5, blah, blah, blah. But here I'll never get something like 2.1472 brothers or sisters. Like, what does that even mean? So that's not a possible answer. So this is example of this discrete data set where it says there are impossible values within a reasonable range. So for example, for the number of siblings, 2.1472 is not a possible, it's impossible values to get. Somebody said 5.14992. Well, what is that supposed to mean? I don't even know what that, in terms of how many siblings, 5.14992 doesn't make sense. So these are all the values that is not possible. So in this case, we have a discrete data set. However, if the question was something like, hey, how long did it take you to commute this morning? How long did it take to commute? Hahaha. Maybe somebody says 1 minute. Somebody says 5 minutes. Well, I have to, but if somebody says 3 minutes, so on and so. Usually it's not going to happen, but what if somebody says 2.1472 minute? I mean, is it not a possible answer? It's a possible answer if you measure it very accurately, right? This is fine. What if somebody says 5.14992 minutes? Well, that's also fine because it's possible, right? So that's an example of a continuous data set where all the values are possible within a reasonable range. Obviously, you're not going to say 24 days or something, but at least within a reasonable range, I can get 2.1472 and I can get 5.14992. So that's just different types of data set. Okay, I'm going to have you pause now and then have you work on number 12. Okay, now let's talk about the next section. This corresponds to book section 1.3. Talk about different measurement levels of measurement. So nominal just means non means like a name, right? So this is basically a qualitative data set. Qualitative. Some numerical measure numbers doesn't really represent numbers. So for example, like your phone number, your school ID or phone number or zip code. Like I live in Eagle Rock, so 90041, but like number is not a count or measurement or anything. It's just basically they're using this number as a name. So if that's the case, our data is levels of measurement. The level of measurement is nominal level. Basically, numbers doesn't really mean number. So numbers are not really numbers, right? Same for your school ID. You get ID number, but that's basically your name, right? It's not like they didn't measure you or count or anything like that. So when we use number as if it's not a number, then we have a nominal. That's called nominal measurement. Ordinal means you can order things. Order, right? So it's numbers that can be arranged from small to large, but it doesn't have to be number. So numbers, obviously, you can order them. But in terms of like you have a shirt size as small, medium, large. They're descriptive, they're qualitative, but somehow we can order them in certain ways, right? Small, medium, large. Or like if you look at the rating, it's like unhappy. You're unhappy with the service. You're okay with the service. You're very happy with the service. So sometimes the survey gives you a little scale. So you can kind of order them in certain ways, right? So it's called the ordinal level of measurement. Next is interval. This is both quantitative. These two are quantitative. Quantitative. So you're measuring them. We're talking about numbers. So interval is when 0 doesn't mean 0. So a few cases I can think of is your temperature. Like 0 temperature doesn't mean that's where the like the coldness starts, right? Temperature 0 doesn't mean like there's no heat at all. Doesn't mean no heat at all, right? So that's interval level of measurement is 0 doesn't mean 0. Same for like our ear. Year 0 doesn't mean this is like start of the time ever, right? Things exist to be before year 0. So year was just like something we decided that's going to be year 0, but that doesn't actually mean that's when the time started. If I had a $0, that means it's like I have no money, right? But if I was born in year 0, that doesn't mean that's like I was born in the beginning of the time. It's not like that, right? And then ratio is basically this is like 0 means 0. 0 means 0. Okay, I'm going to have you pause now and work on number 17, and that's the end of our worksheet number 1.